Okay, the first thing I want to review is I want to review our calendar. So, if we look at our calendar, we have simplifying radicals on page 34. This is called, sorry, 35. This is called simplifying radicals. Where do you think you're going to glue this into your ISN? Page 35. These have the distance formula. What do you think these are going to be glued into in your ISN? Page 37. Okay. For homework, what's your homework going to be? 1 for odds due the 15th. I will try to remind you, but I won't always remember to tell you guys what is for homework. But you should have it written down anyways. So if you ever wonder, if, oh, do I have homework tonight? Look at your calendar. What's due tomorrow? 1-3 is due tomorrow. Okay. So speaking of homework 1-3, this problem here is problem number 15 on homework 1-3. For this one, I want you to actually write it on your homework. Okay, you're not going to write it in your ISN. So does everyone have 1-3 out? Can I use yours? It looks like this. This is problem number 15. It's right here. Someone didn't do their homework. Front and back for that one. You've had this homework for like 3 weeks now.
I totally forgot about this homework. I was too caught up on everything else.
Mm-hmm. Too busy getting hurricaned.
I was saving lives and dogs.
Lives and dogs. That's a noble quest. I guess I'll forgive you.
It is. I'm not lying.
Did I say you were lying?
No.
Yeah. I know. For all 2 people who actually watch them. For like all of 2 people who are going to watch this. Like, comment, subscribe. Okay. All right, guys. So let's work on this problem right here. It says, find the value of the variable and yz if y is in between x and z. So first thing you need to do, how many answers should we have? 2 answers. We should have an answer for the variable, which is a, and an answer for the measurement of yz. Let's look at this part. It says y is in between x and z. So we have x, we have z, and we have y somewhere in between there. I'm going to make it a little bit smaller. Okay, so we know xy is 7x, 7a. We know yz is 5a. And we know xz is, the entire thing is 6a plus 24. Now, do you guys remember the papers we were using?
Yeah.
If we took this piece of paper, this total piece of paper, and we tore it in half, and then we re-added these 2 sizes together, shouldn't it be the same size? That's what we're doing here. This entire thing is 6x plus 24. We split it in half. This one's 7a. This one's 5a. If we combine them together, they should equal to that part. So let's write that mathematically. 7a, this segment, plus 5a, this segment, is equal to 6a plus 24. Are we all good on how I got that? Every single person? It's okay if you're not. Okay. Now it's just algebra. We have 7a's plus 5a's. 7a's would look something like this. There's 7a's plus 5a's. How many total a's do we have now? 12 total a's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 5a plus 7a is 12a is equal to 6a plus 24. Minus 6a minus 6a. We get 6a is equal to 24. What's the opposite of multiplying by 6? Dividing both sides by 6. I'm running out of room. All right, let's do it up here. 6a is equal to 24. Divide both sides by 6. This cancels out. We get a is equal to 4. Okay. Here's a challenge question for you guys. Should that have units or should it not have units? Raise your hand if you think it should have units. Well, let me finish my question. Raise your hand if you do not think it should have units. Raise your hand if you think it should have units. Raise your hand if you don't know. Okay. So, if it is a measurement, it must have units. When you measure something in inches, right? Inches are your units. Are we measuring anything with this variable? No, we are not measuring anything with this variable. So is this variable a measurement in any way? Then should it have units? No. That's why it's okay not to have units on this one. When we find this measurement of yz, it totally has to have units because it is a measurement. Measurements must have units. All right, let's figure out what yz is. Do we have an equation here that gives us yz? Right there. Yz is equal to 5a. Man, if only we knew what a was. Do we know what a is? Yz is equal to 5 times 4. A is 4. The measurement of yz is 20 units because it's a measurement. Okay? Are we ready to move on? Okay. All right, our TEK for today is going to be derive and use the distance formula to verify geometric relationships. Our LO is I will be able to apply the distance formula to find the measure of lined segments. All right, first thing we need to do before we even start doing distance formulas, we need to review simplifying radicals. Radical is the square root sign. There's more than 2 ways, but I'm going to show you 2 different ways to simplify radicals. Then we can have a contest. You can beat me. Simplifying radicals. So far, I'm undefeated. All right, so are we ready to move on? Okay. First method we're going to learn is called the birthday cake method. The birthday cake method, you start with the radical. So we have radical 20, or the square root of 20. Is 20 divisible by 2? You always start with 2, then you go to 3, then you go to 4, then you go to 5, okay? We're going to start with 2. Is it divisible by 2? Yes, it is. We divide 20 by 2, what do we get? 10. Is 10 divisible by 2? What do we get left over? Is 5 divisible by 2? Is 5 divisible by 3? How about 4? How about 5? Yes. So that is a prime number. Okay. So we look at all the ones on the outside, yeah? Because we're looking for things that are evenly divisible by. Because that's not evenly divisible by. We were looking for something that does not have any decimals. Yeah, you can't split it up. Okay, so these are the numbers we have on the outside. We have a 1, a 5, a 2, and a 2. I have a question for you, non-math related question. How many shoes are in a pair of shoes? 2 shoes. So when I ask you for how many pairs we have, how many pairs of the same numbers do we have here? 1 pair of 2s. 1 pair of 2s. Okay? We're looking at the ones on the outside of the cake, not on the inside. So, the 2, I'll tell you. The pairs go on the outside. So we have 2. We have a pair of 2s. Radical, and then what's ever left over goes on the inside. We have a 5, and we also have a 1. What's 5 times 1? 5.
So wait, I mean, why do you have to do the 1? I mean,
You don't have to do the 1.
okay.
I'm just showing that you put all the numbers on the outside. And yeah. Yeah, if there's a higher number, there's 2 pairs of each number. Like, if it looks something like this, I don't know, something like that. Let's change this to like a 5 or something. Then it would be, we have 1 pair here, 1 pair here, right? So those would both go on the outside. You have 2 times 3. What's left over? The 5. 2 times 3 is 6. That would be the answer for that one, okay? Yeah. You multiply these 2 pairs together. Yeah, it's just 1 from each pair. All right, let's look at. All right, so we need to review my rules and my expectations. What is my first rule? No talking while I am talking. Have we broken this rule? So how are we going to fix this? Do I need to start calling parents? Because I need to get through my lecture. Okay, so do we understand? I'm trying to speak right now. I'm trying to teach. You will have plenty of time to talk, I promise, but not right now. Thank you. All right, so let's look at 40. 40 is going to go on the bottom of the cake. Is 40 divisible by 2? Sorry, 40 is divisible by 2. What's left over? 20. OMG, look at that's exactly the same. I wonder if this is going to be the same going up. Is 20 divisible by 2? What's left over? Is 10 divisible by 2? What's left over? Is 5 divisible by 2? 3, 4, it's divisible by 5, right? So, how many pairs of 2s do we have? 1 pair of 2s. I think the biggest mistake people make is they say, oh, look, we have a pair of 2s, and they circle 3 2s. You cannot do that. You can only circle 2. There's 2 things in a pair. So, the pairs go on the outside. What's left on the inside? A 2, a 5, and a 1. 2 times 5 times 1. 2 times square root of 10. Well, I'm glad you're learning now. Hopefully you'll know for your test. Another way to do it is using the factor tree. Factor tree is almost the exact same thing. These are almost identical to me. Factor tree is a little bit more loosey-goosey.
For me, I think it's simple.
Me too. So, what is a factor of 20? 2 and 10, right? If I do 2 and 10, it's going to be exactly the same as we did down here. So I'm going to do 4 and 5. 4 times 5 is 20, right? I'm just doing it to change it a little bit. So we have 4 times 5 is 20. 4 is divisible by 2 and 2. So what do we have? We have a 2, a 5. How many pairs of 2s do we have? 1, so that goes on the outside. What's left over? A 5 on the inside. Is that the same answer as this? Yeah. Let's do the same thing for 40. What's 40 divisible by? 9 times 5? Not quite right.
So, I mean,
10 times 2? Yes, that could work. But I wanted to use a different one. 20 times 5, 5 times 4, no. 20. 40. What's 40 divisible by? 8 times 5. That's the one I was looking for. 8 times 5. 5 is a prime number. 4 is divisible by what? 8 is divisible by what? 4 and 4 is divisible by? How many pairs do we have? We have a pair here and no other pairs. It goes on the outside. What's left over? A 2 and a 5. 2 times the square root of 10. Is that the same answer here? Sure is. Does anyone want to try to give me a number and try to beat me to it? 78? 64? 64 is 8. 64 is 8. 150? 150 is fine. I already know what the answer is, though. 241. 241 was, I'm pretty sure, is a prime number. 242. Let's see. I have to think about this one. 93, prime number. So the answer would be square root of 93. No, wait, 93 is 12? No, 93 is not a prime number. Yeah. No, I don't know. Uh-oh. False information. Let's see, let's do 93. It might still be 93 though. Okay, what's 93 divisible by? 3. And 31. Are those divisible by anything else? No. So the answer would still be square root of 93. I was right.
I don't know what that is.
90 what? 99. That's going to be 33 and 3. That's going to be 11. Okay, that one works. Right? 11. Oops. 11 and 9. 3 and 3. 3 times the square root of 11. 242. 242. That's 1, 2, 1, and 2.
All right, 250. 251.
All right, we're just going to move on. We're wasting time. I already proved that I can do them.
Yeah.
All right. All right. So in your ISN on page 37, I want you to draw these two number lines. 237. Draw two number lines. This number line here, this number line here. They do not need to be perfect. Make them about this big. So don't make them too big. Like that. What? Got what? You don't. Oh, didn't do it on page 38. Mm-hmm.
Where, like, small or?
Not about this big. All right, I'm going to take attendance while we're doing this. The yellow page? That one, that long one doesn't get glued in. Those ones are going to get glued in page 37 or 38. Doesn't matter which one.
Does it matter which order they go in?
No. Pretty good. Kelly? Jessica? Samira? What? Samira. Sorry. Gabriella? Gabby? Jadalyn? Cortisha? Samantha? Kimberly? Marsal? Oh, I'm sorry. Marisol. Frank? Gabriel? Leslie? Danny? John? Elena? Elizabeth? Kaizen. Better? He's just saying, yeah. A little bit better? Kaizen. Zin. Okay. Zinma. Zinma. Z-I-M-E-A. Z-I-M-E-N-A. Zimna. Omar. Andrew. Carlos. Andreas. Juliana. Julissa. Isaac. Elmer. Deriving. And Elena. Is that you? Elena? Okay. Okay, you should have had. What's your name? Yeah, you're here. I got you. Don't worry. What? What did you say? Oh, that was her? Okay. All right, I probably should have turned off the recording while I did this. Okay, so what I told you yesterday on how to solve these ones, find the distance of AB, is I said simply to count them, right? 1, 2, 3, 4. 4 units. 1, 2, 3, 4, 5, 6, 7 units. Okay, but there's an actual proper way to do it. I'm going to show you the proper way right now. The proper way is to use what's called the distance formula, and that's going to be the absolute value of x2 minus x1. So let's call this our x2, let's call this our x1. It does not matter which one you call your x1 or your x2. You can switch them around, you'll get the same answer. Okay, do you guys remember what absolute value means? An absolute value turns a positive number positive, and it turns a negative number positive. Okay? So in geometry, you'll never ever get a negative number for an answer. Well, you'll never get a negative measurement. Okay? Negative 2 is our x2, so we're going to have absolute value of negative 2 minus 2. What's negative 2 minus 2? Negative 4. Are we done yet? We have to take the absolute value of it. When I said an absolute value turns a negative number to a positive number, so the answer is 4. So we know the measurement of AB is 4 units. Is that what we counted? Okay. Do you have to do that?
So if it comes out a negative, you just use that and turn it to a positive, right?
That's what absolute value means. Change it to a positive number. So what this is saying, negative 4, is it's saying if you start here, it goes to the left 4 spaces. But the distance of travel is still 4 spaces. If you start here, it's going to go to the right 4 spaces. Either way you travel, you both go 4 spaces. Okay. All right, if this one was x's, and this was the horizontal plane, right? So if we had a graph, that was x. Once if it's going straight up and down, what do you think you're going to use? A y. So instead of being x2 minus x1, it's going to be y2 minus y1. We'll say this is our y2. We'll say this is our y1. Our y2 value was 4 minus our y1 value was negative 3. Remember, it's the absolute value. 4 minus negative 3 is the same as 4 plus 3, 7. What's the absolute value of 7? Okay. Now, there's a reason why I'm showing you this, and it's not because I want to make it harder for you. Okay. The next thing we're going to do directly relates to this. Okay, I want everyone to put your pencils down. I want you to pay attention to me. Pay close attention. Oh, we're not quite done yet. Okay, I'll let some people finish off. How are we doing on time? I think we're behind on time. $34. Okay, so put your pencils down, pay full attention to me. Okay, this is a pretty tough concept we're going to try to do. So, I am trying to derive this formula right here. This is the distance formula. Now, you should already recognize two things. Do you guys recognize those two things? It's what we just did. So what are we doing here? We're finding the distance between these 2 points, squaring it, and finding the distance between these 2 points and squaring it, okay? So just remember that for now. That's why I showed you that before. Now, what we're going to do is we're going to find, in order to find that, I'm going to start with this example. I want to find, and don't write any of this down. I just want you paying attention right now. Let's find a distance between this point and this point. And you guys should say, oh, easy. It's 1, 2, 3. 3 units. Do you agree with me? Let's find the distance between this one. 1, 2, 3, 4. 4 units. Do you agree with me there? Let's find the distance between this one. 1, 2, 3. You can't do it. You guys are on the right track. What shape? We can't count this. But what shape did I make? I made a triangle. And what they were saying is, can't you use Pythagorean's theorem to find this last half, or this last side of a triangle? You don't remember this?
A squared plus B squared equals C squared.
So in order, this would be our C, this would be our A, this would be our B. So we have A squared plus B squared equals C squared. All right, let's plug it in. Let's figure out what the answer is. We know A squared is going to be 3, so 3 squared plus 4 squared is equal to our C squared. 3 squared is what? Plus is equal to C squared. 9 plus 16 is? 25. Did I ask you for C squared, or am I looking for C? So we need to take the square root of both sides. Square root of 25 is? Square root of C squared is? C. So 5 is equal to C. So we know the measurement from here to here. Why do you think I chose 3, 4? Right? There's more of them. That's called Pythagorean triplet. There's a bunch of them. This is 5. Okay. Now that's all fine and dandy. I know you guys know how to do Pythagorean's theorem. What I care about right now is this formula. Okay. But let's look at this for a second. Pythagorean's theorem was A squared plus B squared is equal to C squared. What happens if we were trying to find C? What did we do to find C? We took the square root of both sides. Do you agree with me? So we have C is equal to the square root of A squared plus B squared. Does this look familiar? Do these two things look familiar at all? Look, we have our square. And we have our square root. The only difference right now is that instead of C, it's saying distance. Okay? Let's look at this a little bit more. Another way we could have gotten 3 instead of counting would have been doing something like x2 minus x1. Do you agree with me? And we know x2 minus x1 is equal to 3 in this example. So instead of substituting in 3, could I have just substituted in x2 minus x1? That would look something like this. x2 minus x1 squared. I substituted this part into a. This square is right from here. I'm plugging that into the formula. And then for the b value, we could have said this is equal to y2 minus y1, right? And we could plug that straight into there. Okay. Now, look at that part there and compare it to what you see there. Do you guys see it? This is the Pythagorean theorem. Or sorry, this is the distance formula. Distance formula is directly derived from Pythagorean's theorem. It is actually the exact same thing. You find the distance here, plug it into Pythagorean's theorem. Okay? That's how you derive it. Now let's do an actual example. In your ISN. So can I use yours? Is it going to fall down? No, okay, we're good. She has her on this page, right? Write this problem here next to this block, okay? You guys shouldn't need more than a couple seconds to do that. Are you drawing pictures instead of paying attention in math class? So write it next to one of yours. So she has hers glued in. Or taped in. Yeah, just write right next to it. We're going to use these squares to solve the problem. Let me see. Yeah, they're all the same. So, we're trying to find the distance between these 2 points. We're trying to find the measurement of PQ, correct? Yeah, that's fine. We're trying to find the measurement of PQ. Do you guys agree with me? And we know PQ would look, I don't know, something roughly like this. 3/4, I don't know, here. 7/2 is like here. This is super rough, right? We can't just count that. That has a diagonal distance, right? We cannot just count that. So we have to plug it into the formula. The first thing you do to plug this into the formula is you need to figure out your x1, y1s. This is your x1, y1. This is your x2, y2. Every single problem I want you to see, I want you to do that, okay? So you don't confuse yourself. It does not matter if you say this is your x1, y1. As long as it's consistent, as long as this says x1, this has to say y1. If this is x2, this has to say y2. Okay? After you figure that, that's the hardest part. After you figure that part out, all you do is plug it into your formula. Right here. Formula's right here. What's our x2? 4. No, it's 7. x2 is 7. Minus, what's our x1? It's okay. What's our y2? 2. And what's our y1? 4. What's 7 minus 3? 4. What's 2 minus 4? Negative 2. What's 4 squared? What's negative 2 squared? 4. It is not negative 4. Negative times a negative is a positive. So negative 2 times negative 2 would be a positive 4. What's 16 plus 4? 20. Is this the right answer? Yes, but we still need to simplify it. We're going to use, I'm going to use the factor tree to simplify. We've already simplified one just like this. Yeah. We have 2 and 10, and then we have 2 and 5. One pair of 2's right there. So 2 goes on the outside. What's left over is a 5 on the inside. So we know The distance from P to Q is 2 times the square root of 5 units. Okay, we're going to stop there for today. That's the answer. Yeah, glue all 3 of those in. Make sure you bring all your pieces of paper tomorrow. Hold on for that for tomorrow. The whole idea of this second piece of paper is so you have your homework here. You take this, you put it like that, and then you put the work on this part.